Okay, we're going to do graphing systems of linear inequalities. We've done graphing lines, so you already know how to graph a line. So the only difference in this is that we're going to be graphing linear inequalities. The line itself, you graph exactly like you know how to do, but then there's some additional things that you need to add to your graph so that it's an inequality. So the first major difference between a linear equation and a linear inequality is the type of line that you're going to draw. There are two families of lines. If your inequality is a less than or a greater than, your line is going to be dashed. If your inequality is less than or equal to, greater than or equal to, your line is going to be solid. Now you might ask, why do we have the different lines? It's because they mean different things. A dashed line is called an excluded boundary. So exclude means to leave out, and a boundary is the line, in this case, between solutions and not solutions. So an excluded boundary means that the line is not part of the solution set. So I always talk about boundary like the fence. You know how in your yard you have a fence between your house and your neighbor's house. At some point, either you or your neighbor built that fence. While some houses share, most of the time it's one person or the other. So if the fence on your yard is not yours, that's an excluded boundary. It still is the boundary between your yard and your neighbor's yard, but you don't own the fence. So yes, it's a boundary, but it's excluded from your property. So that's what a dashed line is. It's the fence you don't own. Now, a solid line is what we call an included boundary. An included boundary is the fence that you do own. So in this case, the line is part of the solution set. So when you graph, you got to make sure you use the right type of line when you draw it through your points. Okay, Roman numeral 2. Direction of shading. Okay, so there are two ways to do shading on your graph or to figure it out. One of them is faster than the other, but you have to memorize the rule. The other way is a little slower, but it'll work if you get stuck. So we'll do the fast way first. The fast way, first of all, your equation needs to be in the form y equals mx plus b, which is already our primary graphing form. So the first rule is y less than mx plus b. And I think of it as y less than the line. If it is less than the line, you shade below the line, which means all the solutions are below the line. Okay, your second rule is y greater than mx plus b. So if y is greater than the line, you're going to shade above. That means all the solutions are above the line. Now, in both cases, it doesn't matter if it's a less than or a less than or equal to, a greater than or a greater than or equal to. The bar doesn't make any difference. It's the direction of the arrow. Okay, so that's your first way to do it. All right, so a second method, which again, it's a little slower, but it will work. Second method, number one, you're going to pick any point not on the line. You can pick any point you want. I usually pick 0, 0 just because I'm lazy, but it can be any point that's not on the line. Step 2, substitute the point into the equation. So you're going to substitute in 0 for x and 0 for y into your equation. Okay, and here's what I'll tell you. If it makes sense, shade over the point. So if your point makes the left and the right true, then your point is in that solution area. You should shade over the top of the point. If it doesn't make sense, then you're going to shade away from the point. Shade away from the point. This means that your point was not a solution, so the shading isn't in the area with the point. It's on the other side of the line. So if your point works, shade over it, that's a solution area. If your point doesn't work, shade the opposite way because your point isn't in a solution area. So what do we mean by if it makes sense? Let's say that you put the point in and you get 9 less than 11. 9 really is less than 11. So this one you would shade over the point that you chose. If you substitute the point in and you get something like 15 is less than or equal to 5, 15 is not less than and it's not equal to 5. So that means you would shade the other way. So the point isn't in the shaded area. Yes?
When you say shade over the point, do you mean where the point is and just that side of the line?
Yes. Exactly. And I'll show you this. We're going to do an example. So I'll show you both methods. All right. So let's do some practice. So Roman numeral 3. All right. So we're going to do the example. Y is less than 3x. Y is greater than or equal to 2x minus 1. Okay, before we do a T-chart to get some points, let's just figure out what we're doing. So this is a less than arrow. It does not have the bar, so your line is going to be dashed. The second one is greater than or equal to. It does have the bar, so the second one is going to be a solid line. Okay, now let's figure out the direction of shading. For the first one, y is less than 3x. So we're going to shade below. Y is less than the line, so we shade below the line. On the second one, y is greater than the line. So we're going to shade above the line. Okay, so we figured out what type of line, which way we're going to shade. Now let's actually plot. So we're going to do the first one. And when you find your points, you're going to treat it like it's an equality. So you're going to treat it like y equals 3x. Even though it's not equal to 3x, that's the only way to calculate the points of the line. So if you remember, there's no fraction on the slope. This has a slope of 3. So I'm just going to use my default 3, 0, 2, and negative 2. And so for 0, 3 times 0 is 0 for the y. For the 2, 3 times 2 is 6. For the negative 2, 3 times negative 2 is negative 6. All right, we're going to draw ourselves a pair of axes. Bigger than a Post-it, use a ruler. And go ahead and plot your 3 points. So 0, 0, 2, 1, 2, 3, 4, 5, 6. And 2, 1, 2, 3, 4, 5, 6. And remember, if you want to label the axes, you can, or you can just label the points. Most people just label the points. Okay, before you draw your line through your 3 points, remember it's supposed to be dashed. So line your ruler up and then go through your 3 points dashed, and then at both ends, don't forget your arrowheads because lines go on to infinity. Okay, when you shade, we don't scribble. We don't scribble. That just gets super messy. You just stripe it, and just stripe it at an angle that's not up, like vertical or horizontal. So I usually just pick some angle, and this is below because y is less than 3x. So I'm going to shade below the line. And you shade from edge to edge on your graphing region. So this means that there are solutions to the first equation anywhere on this shaded area, but not on the line itself. So there's actually infinite solutions to inequalities. That's an infinite number of points in there. So that's why we graph it to show the solutions, because there's so many we can't list them all. All right, let's do the second one. And again, treat it like an equality. Y equals 2x minus 1. Our slope is 2, so you just need 3 whole number points. So again, I'm just going to use 0 to negative 2. So subbing that into the equation, 2 times 0 minus 1 is 0 minus 1, or negative 1. Now the 2. 2 times 2 minus 1, you multiply first. 2 times 2 is 4. 4 minus 1 is 3. And now you're negative 2. 2 times negative 2 minus 1 is negative 4 minus 1, or negative 5. All right, go ahead and plot those 3 points on your graph. Now this equation had an equal to bar, so the line is going to be solid. So when you line your ruler up, you're going to draw a solid line through the 3 points and then put arrowheads on the end of your line. All right, this one is y greater than the line, so we're going to shade above. So pick an angle of striping that's not the same as the one you've already used. So the 2 areas with the single striping are where each line separately has solutions. Because this is a system of 2 lines, and they'll show it's a system either by saying it's a system, using a big brace, sometimes they use a big bracket. The solution area to the system is where both shadings overlap. So the both shadings overlap in this really skinny area. Now, if you don't have a highlighter, that part you can shade in. You can shade it in. Okay, let's say that you ran into some difficulty with shading, and for y is less than 3x, you didn't know which way to shade, you can't remember the rule. So what you do is you pick any point that's not on the y equals 3x line. So I'm just going to pick the point 0, 4. which is right here. It's definitely not on the line. So I'm going to use 0, 4 as my test point, and I'm going to fill 0, 4 in for x and y. So let's do that. So I get 4 less than 3 times 0. 3 times 0 is 0, so 4 less than 0. So the question is 4 less than 0? No, that is false, which means we're going to shade the other way. So on my graph, here is the point 0, 4 right there. Instead of shading the blue line over the top of the 0, 4, I'm going to shade the blue line away from the 0, 4. So that 0, 4 is sitting in the non-shaded area for the blue line. And that's how you pick a test point. If 0, 4 had worked, I would have shaded right over the top of that point because that means it's in the solution area. So if it works, it's a solution, it's in the solution area. If it doesn't work, it's not a solution and it's not in the solution area. All right, any questions about that? Yeah.
How would you shade it?